All righty. Gonna try this as a homework for you and see how it goes. We'll get some feedback on whether it's helpful or not. Enlarge the screen so I get a little better read on what we're looking at. All right, so you got 12 problems in front of you. And let's just mechanically do them and save conceptual conversations for in class. Maybe I'll make a comment here and there. It's pretty hard not to when I'm first learning how to do these problems. So we've got X's and Y's, inputs and outputs, data. And we're trying to understand what's going on here, and this is linear, so therefore it's a something to the first power. And that's where all the change is occurring. The change that we see in a problem isn't the change that we need to get where we have to go in terms of data. We got a marker and we can make adjustments. So I've got the number 9 here. I want to turn it into a 7. That's an input. I put it in and I want that. Well, this number is not the one I want, so I'll get rid of it. This is the number I want. Now, normally we don't put the 1 there, but I want to really highlight it in the early going here. So now we take our second input and we've got to get a 12 out. That's our Y value that we want out. We want to get a 12 out. And so 15 minus 9 is 6. 6 plus 7, not 12. So I don't want this thing to change by 6 units. Cancel that with a little division. Undo it. That makes the number 1. So how do I get from 7 to 12? I turn the 1 into a 5 with a little multiplication. And now we have that equation. I wish that textbooks were X to Y, but of course it's a math class, so we got to do Y equals. Unfortunate. All right, so that's that problem. Now, this is the quadratic. Quad. Latin for 4. Oh, rectangles have 4 sides. But length times width equals area is basically what we're creating here. And we're going to do it with squares. All right, so the major operation is squaring. Get that in. Now I want a -2 to turn into a 1. Well, I can still do that with the same technique I did over here. When I put a -2 in, I get 0. 0 squared is the minimum of a quadratic, by the way. Can't get smaller area than 0 when you square things. And I want a 3, so there we go. Remember, I'm trying to get these Y values. So -2 is now correlated with 3 when I put a 1 in. I get some change here. I'm moving from 3. I know from 3 to 17. I know I've got to add 14. That's a given. 14 and 3 is 17, provided I get some cancellation. Well, this cancellation is one more operation of numerical change than the previous one because it's a 2-dimensional picture. So I drop a 1 in and I get 9 units of change. Well, 9 plus 3 is not 17. I get rid of that operational change. And that's the equation that passes through -2, 3, and 117. So let's put 117 here. And it's always good to check it with, maybe we'll look at the Y axis where X is 0. All right, because if this is true, then a 0 should give me a number, an output between 3 and 17, because 0 is between -2 and 1. So it should be bigger than 3 and less than 17. We'll put a 0 in, and we get 4 times 14 is 56 ninths. 56 over 9 plus 3, and 3 is 27 over 9. And that's 83 over 9. And I know 81 over 9 is 9. And 9 is certainly between 3 and 17. So I got a little quick approximation there of, yeah, this seems to be collecting the data nicely. All right, so what is your homework? Your homework is, if you're following this, then I'd like to actually see you write that 1. That way I know you're connecting with the video. We're not going to spend a lot of time here, but we're getting started, so I'm trying to explain the process a little bit. Okay, so now I can erase this. You can always go back and look at it, but I'm going to give myself a little room here. And my hope is that in class that you've already had now this morning, that we have talked about exponential rules. I've established the M process, M to the 2, M to the 1, M to the 0. M to the 0 is, there's no difference in the number of factors in the numerator or the denominator. And so therefore, something divided by itself is 1. This is key. We're going to be developing that in big ways to be helpful. And as we make more factors in the denominator, well, then we have the negative, which means that there's a heavier influence in the denominator in the factorial process than the numerator. All right, so we had that discussion, I hope. And I hope we had the discussion about m squared, what undoes m squared. Well, that certainly cancels squaring. So what cancels squaring? Square rooting. All right, and so therefore, if you saw something like that, m to the 1/3, you're trying to learn the language that means the cube root of m. So I'm assuming we had that discussion. So I'm just going to do the problems now. So log 64 base 4, 64 to the what? All right, so that is basically asking the question, what exponent you put on top of the 64 to get a 4? All right, so we need the same base. Well, 64 is 4 cubed. All right, and this is 4 to the 1. I've got the same base, so the exponential activity, multiplication in that case, I probably have to derive that. That tells me I probably got to spend some time this morning teaching that. And so therefore x equals 1/3. We just talked about that. 64 to the 1/3 is the same thing as saying the cube root of 64, which happens to be 4, because 4 times 4 is 16 times 4 is 64. So that's the cube root of 64. All right, so that one's done. Next one. Oh, I just erased one. I think it was 4 to the -3/2. I'll check that in a moment. So log base 5 of 1/125. So logarithms really are trying to express this quantity in base 5 notation. Well, 125 is 5 to the 3. All right, and I'm hoping that folks recognize that 1/5 to the 3 eventually is the same thing as 5 to the -3. That -3 represents that you're cubing the number 5 in the denominator. So what is the exponent that you put on top of 5 to get 5 to the -3? Well, sure looks like -3. So that's that answer. That's the exponential activity involved in that problem. All right, I'm hoping that this is the problem that you're doing. 4 to the -3/2. That's on the sheet because I just accidentally erased it there. All right, so you can do 4 to the -1. You can take the square root of it and you can cube it, or you can take the square root of 4. You can cube it, and then you can do it to the -1. All right, so what does that mean? It means you got to identify that the minus sign means make a reciprocal. Right now it's 4/1, it's going to flip. Cubing, well, we just talked about cubing. 4 cubed 64. And we're trying to recognize what that operation is, square rooting. And it doesn't matter the order you do these things in. So what's the easiest operation to perform? The one that makes the simplest number come out. Well, to me, that's square rooted. So I would take the square root of 4, which is 2. Hopefully, you've heard this again in the last problem. What's 2 to the -3? That's 1/2 cubed, which is 1/8. Now, the repetition of this might have just served you well to get in there. If so, you're learning. So you're going to copy that process down. You're going to do that. 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 Okay, and that tells me you saw this video and you heard that. It doesn't take more than 10 seconds to look at a particular type of equation or calculation to get a little practice. Kind of like word of the day. Where am I? Oh, I'm on the other side. Came prepared. Couple more problems. I think I wrote on the sheet key moment. So I want to talk about what I mean by key moment. So in your pre-algebra, I'm assuming you might have done a little of this. If not, don't worry about it. Let's just show you what this is about. 2 + 5 times 7 - 3. All right, just as an example. All right, I'm not going to do the full drawing here. But that's 7, that's 4, 7 times 4, we know is 28. Well, where does it come from? Well, the distribution, 2 times 7, 14. 2 times -3, -6. 5 times 7, 35. And 5 times -3 -15. You take the time to add that up, you're gonna get 28. So that's just showing the mechanics of the problem here. So what are the mechanics of the one above us? We got 3x times 3x, 3 times 3 is 9. X times x is x squared. 3x times -7 is -21x. Another 3x times -7 is another -21x. And -7 times -7 is 49. And that's doing it out, taking time to do it out. Just look at your answer. Anytime you're doing a problem, just tuck your answer underneath. And I'm gonna do that now, right here. So this is 9x squared. There's 2 of those, so that's -42x. And positive 49. Now, could I get that answer without having to do it out in that distributed process? I mean, I want you to see the distribution, you're just learning this stuff. But at the same time, if you understand that, and that makes sense to you, then you look at this and you go, could I have just written the answer? Well, let's find out. How do you get 9x squared from this? Well, you got to square the first one. Well, could I do that over here? Could I square that? 3 times 3, 9. X to the 4th squared. What does it mean to do x to the 4th squared? You're just learning math here. X to the 4th is x times x times x times x. And I'm multiplying that by x times x times x times x. And I don't need that dot because there's a dot between each of these multiplications. X times x, x times x, so on and so forth. So count them up. You got 8. Does that give you a big clue as to what you're supposed to do here? Hopefully so. All right, so that's what I'm doing over here. Okay, so this is x to the 8. And then we look at this and we go, oh, -42. Could I see -40? Well, I can certainly see what that is. That's -21. So it sure looks like if I did that and doubled it, I'd get this answer. So over here, I think that product is going to show up twice. That's -6, 3 times -2, times x to the 4th a. And I got another, and I got another -6, x to the 4th a. Well, that sure looks like -12, x to the 4th a. And then, of course, you square the last term, which doesn't matter, right? It's always going to be positive. -7 times -7 is positive, or +7 times a positive. So it's going to be positive. All right, and then all you got to do is square the 2 and square the a. And now you can get a working knowledge of what's called binomial squaring. All right, may have bitten off too much here. Not sure how much new material we can get in the early going here, but this is a very important topic. Y equals 2x squared minus 12x plus 7. All right, let's try to just do the mechanics and really try to develop where this all is coming from as we go through the semester. This is a very important calculation, and so we want to give it a lot of attention. But what's the initial things that you can see, hopefully? I see squaring, and it's positive squaring. Cup shape up. What else do I see? I can see a nice data point. Plugging in a 0, gets rid of those 2 terms, gets me a 7. That's the y-intercept. We'll come in with that later. I know it's on this side. I have to explain at some point in the semester how I know that and how I want you to know it, but it's going to appear here. I need that x value. We will develop in class this week why it's minus b over 2a. That's going to get me the most important x value. So minus b, the opposite of minus 12, positive 12, divided by 2 times 2 is 4. I now know that that number is 3. If I know that number is 3, then I can write x minus 3 squared. Now the question is, what goes with a 3? Well, I got a calculation that takes inputs and tells me what goes with them. So why don't I use it? And I get 18. I know the next number is minus 36 for geometric reasons, which we will cover during the semester. Don't even have to look at it, but I am 3 times. It is 2 to 1. That only happens at one location on this calculation for geometric reasons, which we will discuss later. All right, and the shortcut here is whenever you add these two numbers, you always get the opposite of the first one. So this is minus 18 plus 7, and that's equal to minus 11. As I said, I also know that 0, which is to the left of 3, gets me 7. And we will check this. So to put this in graphing form, x squared, I need 2x squared, so we just take it. If we expanded that, which I think I'll do for you, but we also know that that is another way of expressing this area. Just another way of expressing. Numbers are the same. How about we put in a number like, what's easy, 5. I'll put a 5 in here. 25 times 2, 50. 5 times negative 12, minus 60 plus 7. Minus 10 plus 7 gets me negative 3. When I drop a 5 into this calculation. If I drop a 5 into this, I better get negative 3 or it's not the same calculation. 5 minus 3, 2. 2 squared, 4. 4 times 2 is 8. What's 8 minus 11? Oh, negative 3. Now, again, we're just starting this homework process. So what do I need to see from you? I need to see from you that y equals 2x minus 3 squared minus 11. That's what I'd like to see. And what I'd like to see you do with this is to check that it is the same by employing the skill we practiced earlier, which is the following. Square the first term. I'm going to move that a little bit further. Double the product. Minus 3 times x, minus 6x. Minus 3 squared, positive 9. Subtract 11. Let's do this out. 2x squared minus 12x plus 18 minus 11, which is equal to 2x squared minus 12x plus 7. Bingo, bango, bongo. It is correct. Okay, so you're just make sure you put something down for each problem and turn it in, and we're going to be good. That's enough practice for tonight. See you tomorrow.